How do you feel about it? Did you guys do well, bad, not as expected? I never failed. Mostly I think so. That was so funny. You did not receive the exam back yet, right? No. Probably will receive it today, right? Okay. Mhm. Okay, so today, we're doing week 5, and after a bit, I'm going to give you week 6. Next week, Monday there is no class, and Tuesday is a Monday schedule. Okay. So even though we're supposed to meet on Tuesday for Monday schedule, but I'm canceling our next week's recitation. So next week we are not going to have any recitation. We're supposed to do week 6. I'm going to give you week 6 today. You try them on your own. If you need any help, we can discuss everything when you come back after 2 weeks. Okay. And today we're going to do week 5, which talks about and the first page talks about domain, particle asymptote, knowable single vector thing. And in the second page is supposed to match the graph with the equations. Well, if you know few story behind rationale, everything will be easier for you. Okay. So let me tell you, what do you need to know? What are the most important things about rationale? Oh man. Sorry, my thing is not working. And also I have your old recitation. I'm going to give them that. Okay, cool. So first thing, domain. To find domain, we set the original denominator not equal 0, because we know we can never have 0 in the denominator. So denominator can never be equal to 0. So we set the original denominator equals 0 and we solve for x. From there, it comes vertical asymptote. We do the same thing for vertical asymptote, but we do something different. We set the simplified denominator equals 0, and we solve for x from there. Simplified means we can simplify our function somehow. Maybe we can factor them, maybe we can do something else. And once we factor, we can cancel something from the top, from the bottom. Like if there is any way we can do something on your function, then whatever remains after doing that, whatever remains, we call them simplified. Okay. So simplified denominator, we set it equals 0, and you get the vertical asymptote. Vertical asymptote gives us dotted line, means where our graph breaks apart. Next, we have removable singularity. And we got them from the cancelled term. When we tried to simplify, most of the time we can cancel something. So if we can cancel something, we said that cancel term equals 0, and we solve for x. If you cannot cancel, that means you don't have any removable singularity. When you can cancel, we have an x value, and to get the y value, for that x value, which is solved from there, substitute x value to the simplified function. That means in order to do everything else, you need to simplify a function first, except for domain. Domain takes the original denominator. Except for domain, for everything else, first you simplify your function and then go ahead and find everything else. What do you get from here? We get a whole from that removable singularity. From the particle asymptote, we get particle line, which breaks our graph apart. And from removable singularity, we get a hole in the graph. It doesn't break our function, it just gives a hole in the graph. Then let's say I want to find x-intercept. To find the x-intercept, we said simplified numerator equals 0, and this solve for x. You see, again, simplified. Everything else is using simplified, except for domain. We all know how to find y-intercept. It has only one rule. Not set. Log is better words. Log 0 for every x and solve for y. It doesn't matter where do you plug in. You can plug in the original one, or you can plug in the simplified one. It doesn't matter. You get the same results anyway. And then comes the last one, horizontal asymptote. Horizontal asymptote has 3 rules. If we have a function y equals x to the highest degree of our highest degree on the denominator, so we don't care about everything else, we care about only highest degree. Highest degree on top and bottom, means numerator and denominator. So observe the highest degree on the top and highest degree on the bottom, including their coefficients. When you observe them, you have 3 scenarios. If the numerator is bigger than denominator, then we have no horizontal asymptote because our numerator is bigger. We cannot control our numerator. However, if they both are same number on the top and bottom, they are the same degree, our horizontal asymptote is y equals the coefficients they both have. Coefficients on the top divided by coefficients on the bottom. And finally, if the denominator is bigger than numerator. So our denominator is heavy, it's very heavy. And whenever we have a big denominator, we always go to 0. regardless of what degree you have, we don't care. If the denominator has the highest degree than the numerator, it's always y equals. What do we get from here? We get horizontal line that usually we don't cross. But we are allowed to cross sometimes, but usually we don't. But we can never cross vertical asymptote. It's impossible. But we can cross horizontal asymptote. It depends. So these are the 6 things you should know to work with any type of rational expression. Any questions so far? Did the instructor teach you this? No. Okay. So now since we have all the information we needed, we can go ahead and apply them into our examples. The first one is from question 1. 1C. It says compare two functions. Tell them how they're different. But you must find domain, particle asymptote, renewable singularity, and figure out how they are different. Well, they look different, right? But actually they are not different. There's only one difference between them. Otherwise, they want the same function. They have the same shape, same particle asymptote. They are very same, but not real same. So let's start with domain. For domain, we take the original denominator. So we have this in the denominator, we have this on this denominator. So for f, x squared minus 4 cannot be 0. And for g, x cubed minus 4x cannot be 0. Because it cannot have 0 in the denominator. So I'm finding domain for both functions at the same time. Okay, what can we do next? Our goal is to solve for x. We can do square roots. Not yet. But instead of doing square root, can you factor them? Is it possible to factor this x squared minus 4? What factors you get? So x plus 2, x minus 2. But g, we cannot factor g this way, right? What do you notice in g? We have a common factor. We have a GCF, x. They both have x in them, so we can pull out an x, and we get x squared minus 4. Well, we know we can factor this more, so we get x plus 2, x minus 2. None of them can give us 0. That means x plus 2 cannot be 0, and x minus 2 also cannot be 0. That tells us we cannot plug in x with negative 2 and x with positive 2. In here, there are 3 numbers we cannot plug in for our x. 0, negative 2, and positive 2. So see, we found our first difference. For domain of f, we have only 2 numbers that we cannot plug in. Positive 2 and negative 2. But for g, there are 3 numbers we cannot plug in. If you try to plug them in, we get 0 in the denominator, everything becomes undefined. So we found our first difference. But if you want to see it in number line, from negative to positive infinity, we can plug in everything for f except for these 2 numbers. So negative infinity to negative 2, negative 2 to positive 2, and positive 2 to infinity. This is our domain in interval notation for f. But g has more problem. we cannot plug in -2, we cannot plug in 0, and we cannot plug in +2. 3 numbers we cannot plug in our function for g. That gives us 4 intervals. -∞ to -2, -2 to 0, 0 to +2, and finally +2 to infinity. Basically, we are saying that we are taking everything from the number line except for these 3 numbers. Any questions so far? No question? Please feel free to ask me anything, okay? Anytime you bump into any question that you don't understand what I'm explaining, always ask me a question. Don't think it's silly. Right. When you cannot use something, it means parentheses. That's its parentheses for all the numbers. So we found our domain, so we found our first problem. Next, let's modify our function. So f of x, the original one is 1 over x squared minus 4. Well, we have nothing to modify here. We can simply just multiply, we can simply just factor it. That's it. For g, we have x over x cubed, minus 4x. So we already know if you factor the denominator, we get this. And now do you see something? Can you cancel something here? X. So it's 1 over x plus 2, x minus 2. Look at f and g. They are same function after we cancel them. See? They're exact same function. But still they're not same. Why not? Because we cancel something. Since we cancel something, so from the cancelled term, we get removable singularity. We set the cancelled term equals 0, and from there we solve for x. So we cancelled x, we set x equals 0, and we don't have to solve anything, it's already solved for us. Well, removable singularity is actually a point. Why do we care? Because every point has 2 things, x value and y value. From there we found x value. So we need to know our y value. So to get the y value, we use the simplified version. If you try to use the original one, it's not going to work. You get something undefined. So you must use the simplified version to get the y value. Our simplified version says we have x plus 2 means 0 plus 2. And x minus 2 means 0 minus 2 in the denominator. So we have 1 over 2 times -2. That gives us 1 over -4. Why do you care? That's because we have a whole at x value 0, y value -1/4. Removable singularity leaves us a hole. Vertical asymptote just breaks graphs apart, but removable singularity or removable discontinuity, it means it just leaves a hole. That's it. We don't have a valid y value. We're supposed to have a y value -1/4, but actually we don't. We have a hole in the graph. Now let's find vertical asymptotes. How do you find vertical asymptotes? We set what? simplified denominator because we have two denominators. Right? One is the original one is the simplified one. Set the simplified denominator equals 0, and we solve for x. So for f, our denominator is x plus 2, x minus 2. We set it equals 0. For g, we have the same thing, x plus 2, x minus 2, we set them equals 0. Well, from both, we get x equals negative 2 and x equals positive 2. Right? They have the same simplified denominator. So we don't have to do it twice. We can simply do it once, and this is same for both of them. Now, finally, the last thing, horizontal asymptotes. So since the simplified version for f and g are the same thing, we can simply write f of x equals g of x equals 1 over x plus 2, x minus 2. Now, compare the x value on the top and x value on the bottom. Which one has highest degree? Which one has higher degree? On the top or on the bottom? On the bottom. The top doesn't even have any x. So x has higher degree on the bottom. So horizontal asymptote is automatically y equals 0. And this one doesn't have any x-intercept because our numerator doesn't even have any x concept, any x term. So numerator doesn't have x, means no x-intercept. No x-intercept since top has no x term. And if you want to find y-intercept, it's y equals 1 over 0 plus 2, 0 minus 2, that gives us negative 1/4. So it's supposed to have y-intercept negative 1/4. For f, we do have negative 1/4, but for g, we don't, because g has a whole, f doesn't. Who is confused? Anybody? Is there any question up until all the points I described? No? Okay then, let's apply all the knowledge and see what happens in the graph. So we have to do two graphs, my bad. One is for f, one is for g. This is f and this is g. So they both have two vertical asymptotes. One is at negative 2 and one is at positive 2. Negative 2, positive 2. We have two vertical asymptotes for both of them. Y-intercept for f is somewhere here. 0, negative 1/4. For y-intercept, we don't have anything here. We have a hole here. So it's a hole here. Y, this is x. G function has a hole when x is 0, y is negative 1/4. And f function doesn't have any hole. And we do have a y-intercept, y equals 0, means on the x-axis, we have a horizontal asymptote. There is no x-intercept. So we have three parts in our graph. How do you know which part is what? We have to check at least one part. Okay. So we already know in the middle we are never crossing x-intercept because we don't have any x-axis. Sorry, other way around. We are never crossing x-intercept x-axis because there is no x-intercept, right? So if you cannot cross the x-axis, how are we supposed to draw the middle part? Upside down parabola, right? Because we cannot cross. Let me change the color. Something going. We cannot cross our x-axis. Since we cannot cross the x-axis, but we do have y-intercept below x-axis, that means the only thing we can do is have the upside down parabola in the middle. Now, there is some rule for vertical asymptote. Let me tell you that before I give you the next part of the function. There are a few rules. Do you have more page? Okay. Rule. On behavior, sorry, my bad. I should write behavior. Behavior near vertical asymptotes. So how do we know where our graph should be in the left or in the right of the middle point? Well, it's easy if you know these rules. If denominator has any factor, what's wrong with my pen? With even power, then the behavior near vertical asymptote will be one of these. Either they both are going up and you have a vertical asymptote in the middle, or they both are going down and you have vertical asymptote in the middle. So one of these two scenarios. Near the vertical asymptote, both ends of the graph will go upward or both ends will go downward. If the denominator has even power factor, like if a factor that is even power. If not, if the factors on the denominator has odd power, then we have two scenarios. Either one of them will go up and other one will go down and you have vertical asymptote here, or one end on the right will go up, the other end on the left will go down. So two scenario. We have vertical asymptote. If one side go up, the other side must go down. Or if one side is going down, the other side must go up. That's the rule. For any odd power, this is the rule. For even power, they must follow the same direction. Now look at our graph. Our function is y equals 1 over x plus 2, x minus 2, for both of them, right? After simplifying everything. Now, what power we have on x plus 2? 1. And x minus 2. They both are odd, right? That means if we know for sure that this end is going down, where our next graph will be? Here or on the top? It has to be on the top because we have to go upward here. And it should be above the x-axis because we have a horizontal asymptote on the x-axis and we don't have any x-intercept across. So this portion is going down. We know this is the y-intercept And the rule says if this goes down and they don't have it covered, so it must go up. Same thing, this end is going down. So what will be the other end? Up. So we have another portion going here. And on the left and on the right, they're going forever. They never cross the x-axis because we don't have an x-axis. We have an x-axis. So you see, we did not plug in any numbers. If you don't remember the rules, no problem. All you have to do is keep plugging numbers and see how they work. Okay? And if you do remember, you don't have to do any math. You just figure out one of the portion. If you can figure out one of the mini parts, then you know the rest. Especially try to figure out the middle, because the middle is the harder one. Middle has two choices, either these or sometimes actually they cross. Or it could be this way, or it could be this way. Middle has so many options. So anytime we don't know what is happening in the middle, always start with the middle. Find out what's the shape in the middle part, and based on the middle part, you can figure out the ends. Clear?
Okay, can you repeat when there's a whole like G and
Okay, so we are not done yet. So we know we have a graph that is going down in the middle, going up on the right, up on the left. But here we have a hole. We have a hole at G because we cancel something in G. Remember we cancel zero? Anytime we cancel something, whatever we cancel, it gets so angry. It says, well, since you're canceling me, you know what I'm going to do? I'm going to leave a blank spot in your graph. So you know you will not be perfect. The F is perfect. It doesn't have any problem. But G is not perfect. It has a hole, a blank spot. So cancel something, it gets angry, leave us a hole. Question? Any other question? No? Okay, then try the rest by yourself and let me give you week 6 because we are not going to have any class next week. And also I'm going to return your previous recitations. Why is my week 6? Okay, let me get everything back. Try by yourself and then I'll not here, not there. That is so weird. I printed out week 6. I'm pretty sure I brought them here. These are your old ones. These are the new ones. I'm so lost. Well, even if I don't give you, you can print them out from the home. Do any of you have week 6 from the table? No. Oh, yes. Let's do that. No. For next week, Monday was school, and we have to read the Monday schedule. But Tuesday we are not going to meet. Only for us, I'm giving a break. Instead, try the repetition at home. If you have any question, we can go over those questions on the calendar after 2 weeks. And if you have anything to give me, you can give them to me. One is most important.
This was my work.
Week 6 is for homework, okay? Not now, not today. You're gonna do week 6. I mean, you're gonna do week 6 at home, and you're gonna start if you need help later.
Using numbers. I mean, using numbers elements we come with the same spell that we would have.
Right. We see you think of it as Monday.
Right.
I've got all of your Monday.
We just don't have this.
Only different field right. And right. The original denominator not equal 0 and also for us from there. Pause the recording. Where is it? Question 2C. We have f of x is 3x minus 4 x cubed minus 16x. Even though we cannot do anything on the top, but we can do something on the bottom, right? So let me do it this way. They both have what? X in common. So we pull out x and we get x squared minus 16. But can you factor more x squared minus 16? What do you get? What's the square root of 16? So you do plus 4 minus 4. That means our f of x is 3x minus 4 over x times x plus 4 x minus 4. Can you cancel anything from the top and bottom? What can you cancel? We cannot, because on the top it's not factorable. Since we cannot factor, that means we don't have any hole in our function. So that's a relief. We have a continuous function. Only problems we have are the vertical asymptotes. So you go to the denominators and we set each of them equals 0. The first denominator equals 0. It's already solved. We have nothing to do. So you're done. The second one is x plus 4. We set it equals 0. That gives us x equals how much? Negative 4. And then the last one is x minus 4 equals 0. That gives us x equals positive 4. And now on the denominator, does any of the factor have any even power? No, right? That means for every one of them, the one side of the vertical asymptote will go up, the other side will go down. Okay, so that's we know. And horizontal asymptotes. What is a horizontal asymptote here? For this function. What is the highest degree of the x on the top? And what is the highest degree on the bottom for x? X cubed. So which one is bigger? Bottom. And anytime bottom is bigger, it's always y equals 0. Not any other number, it's always y equals 0 when the denominator is bigger. So we have a horizontal asymptote on the x-axis. We have 3 vertical asymptotes and we have no holes. Great. Let's figure out x-intercept. Actually, let's do it here. X-intercept. How do you find x-intercept? What do you do? Come on, guys, I gave you all the information already. Set the top. We don't care about the bottom. Bottom gives us vertical asymptote. So we set the simplified top, but here we did not simplify anything. So whatever we have, set the top equals 0, and we solve for x. So we have 3x minus 4 equals 0. That gives us x equals how much? 4 over 3. So it's like 1 and 1/3, right? 1 and a little bit more. For the y-intercept, we set all x equals 0 and we solve for y. So y equals 0 minus 4. Uh-oh, we have 0 on the bottom. That means no y-intercept. So we are not crossing y-axis ever. Oh, that's because at 0 we have vertical asymptote. We cannot cross it. Okay, so we have no y-intercept. We do have x-intercepts. So one of the vertical asymptote is here at 0. So let me actually draw like this. This is our y, this is our x, and we have vertical asymptote at -4. Let's say this is -4, and we have at +4. Let's say this is our +4. We have -4, +4 at 0. This is 0. And we know our x-intercept is what? 4/3. It means when x is 0, our y is 4/3, somewhere here. Right? When x is 0, no, this is y-intercept. X-intercept is the other way around. 4/3 here, sorry, my bad. 4 over 3. X-intercept is lying on the x-axis, not on the y-axis. Okay, and we have a horizontal asymptote here. You see, even though we do have a horizontal asymptote at 0, but still we're allowed to cross the x-axis because in the middle. In the middle, we can cross x-axis, cross the horizontal asymptote. But at the end, we cannot cross the horizontal asymptote ever. Okay. So we have a problem. We don't know what the shape in the middle. Since we know we have an x-intercept here, so let's see what is happening before and after x-intercept. Let's say our x is 1. When x is 1, what do we have here? 3 times 1, actually let me do it here. When x is 1, our y is 3x minus 4, x times x plus 4, x minus 4. So that gives us 3 times 1 is 3, 3 minus 4 is -1. And then we have 1, 4 plus 1 is 5, 4 minus 1 is -3. I'm just finding out y value based on the x value. So we have -1 and then -15. That gives us +115. That means somewhere here. So what happens after our x-intercepts? Let's say x equals 2. We have y. I'm showing you all the details instead of picking, because in the exam, you're not going to pick a graph. You're going to draw the graph. Okay? So you have to sketch the graph. How you're going to sketch a graph, I'm showing you the details. And guess what? In the final exam, you have to do one of them. If you didn't do it in the in-class exam for the exam 1, you're going to do it in exam 2, right? So see, I'm helping you. So we have 3 times 2 minus 4, 2 plus 4, 2 minus 4. So we have 6 minus 4, which is 2. 2 plus 4 is 6. 2 minus 4 is negative 2. We cancel them out. We have a negative number, negative something, negative 1 over 12. Right? Negative 1 over 12 is somewhere here. Now, can you guess what will be the shape in the third part? It's a cubic. It's an inverse negative cubic. So you must have something like this. So let me change the color. Based on the points we plotted, this must be the shape. In the middle, it's crossing, it has this shape. Now we don't have to do anything else because we know the rules. None of the factors that have hidden power, right? So if this side is going up, what happens here? It must go down. Well, we do have a problem. When it's going down, actually don't. We don't have any more x-intercept. So this is going down and we don't have any more x-intercept. So what would be the shape of this side? Is it going up or is it going down? It must go down because we can have cross x-intercept. We don't have any more x-axis. So we don't have any more x-intercept. What's wrong with me? So the second part of the graph, both sides must go down. And since this is going down, that means this has to go up. So it stays above the horizontal asymptotes. That means we have only this option here. Because this is going down, this must go up. If one goes down, another one must go up. Now, which of the graph matches with this description? A, B, C, D, E, F. Which one? See? Here you are matching, but in the exam you're not going to match. You're going to sketch the graph. So you need x-intercept, y-intercept, vertical asymptote, horizontal asymptote, and then just plug everything in. When you get stuck, no problem. Plug some points and figure out which path would be the right path. So, any question before you leave? No? So if you're done, you can submit. If you're not done, no problem. Remember, next Monday, no class. Tuesday is a Monday schedule. But for us, there is no recitation. I gave you week 5 and 6. Complete them, bring them back in after 2 weeks. What's the name? I don't, because whatever I have, I submitted, but I'm still having some of the recitation at home. So maybe your recitation are in there.
Thank you.
Like,